not here. Okay, so we're officially starting our quadratics unit. This unit is going to last for our weird schedule. It's going to be this week, and then it's going to continue on when I see you again. So basically, it leads up to December break. You are going to have an assessment on Friday as usual, and then another one on the Friday when I see you next. You guys know how in grade 9 we learn about the line. We learn everything about the line, linear systems. We learn about y is equal to mx plus b. We calculated the slope. We learned about standard form and all of that stuff, perpendicular. We're now ready to learn about a new shape. And so that's what a quadratic is. So we're now going to be talking about a line that is not linear. It's non-linear because it's curved. And that's basically what this entire unit's about. We're going to introduce the topic of what a relation and function is. Then I'm going to talk about what the word quadratic means. And then we're actually going to get into graphing today. And then we're going to continue graphing tomorrow. So I know I've given you a lot of sheets, but they're actually not going to be too much work. It's just a lot more like charts and looking at it. So take a look at the first one. The very first lesson in this unit is talking about what is a relation and what is a function. So you can have something called a quadratic relation, or you can have something called a quadratic function. And there's a big difference between those that we need to talk about. So a relation is any set of input that has an output. What that means is for every x value, there will be a y value. So I can, like, if I were to, oh no, my program's not working. 1 second. So when we're talking about input and output, we're really just talking about your x values and your y values. There we go. There we go. So when we're talking about relations, it's basically anytime you have a relationship between an x value and a y value. So if I were to give you a point like 2, 1, and then 3, 4, you can see every one of the x values is paired up with the y value. That is called a relation. Okay, they have a relationship, the x and y values. But in order for a relation to be a function, each input must have only one output. So that means for every x value, you have to have only one y value. You can't have multiple different y values. That definition is kind of hard to wrap your head around. The best way to think about it is with the examples I'm going to show you. So another way to think about it is meaning x's can't repeat and graphs must pass something called the vertical line test. Okay. And also all functions are relations, but not all relations are functions. I'm going to come back to all these definitions, but let's just start looking at the examples. So in this first column over here, I have these are examples of functions. So only one output for every input. And for this column over here, these are everything that is not a function. So let's look at ordered pairs. What do you notice about the ordered pairs under the function column? And then what do you notice about the ordered pairs in the not a function column? Tell me if you notice a difference of something. Safir? Okay, so you had it right. Do you notice how you have a 6 over here and then you have a 6 over here and there's a repetition? And do you notice how you have a 1 over here and you have a 1 over here and there's a repeating x value? But over here, every x value is different. 1, 4, 5, 9, those are all different. 2, 4, 6, 8, those are all different. So when you're looking at an ordered pair, you're looking at the x values. And the x value is always the first one. Remember, when you're writing an ordered pair, this is x, this is y, x and y. If you notice all of your x values are different, then it is going to be a function. But if you notice that you have a pair of x values or multiple x values that are the same, it is not going to be a function. And that's what it means. For every input, which is your x value, there's only one output, which is your y value. Can't have repeating x values. Okay, let's look at the table of values. So this table of values represents a function, and this table of values does not represent a function. What do you notice is different about them? I want to change my color. Jordan, what do you think? Yep. So do you notice how in the function there are 0, 1, 2, 3, all of the x values are different. However, in the table of values that is not a function, you have 2 13s. Well, that means this x value has a y value and this x value has a different y value. That makes it not a function. So it doesn't follow the rule that every input only has one output. In this case, this input and this input have 2 different outputs. Okay, so really the easiest way is look at the x values. If you have a repeating pair, it is not a function. If they're all different, it is a function. Samir? Perfect. Yep, and that's what we were getting at, but you actually nailed it. So let's just talk about what the graph would look like, and then that would give you a little bit of an idea of what we're talking about. So if we were to graph this stuff over here, let's say 13 and 3 is like here, 9 and 4 is maybe here, 11 is going to be between there, and 8 is here. And then we have a 13 and another 4. So do you notice that I have a pair of dots that are on top of one another? As soon as you notice you have a pair of dots that are on top of one another, that is not a function. Oh, it's completely off. Sorry. So I kind of just plotted the points. I'll actually spread them out a little bit so you can see more clearly. Oh no, why is it frozen? Why is it frozen? I do have to say the internet is doing quite well. So let's say there was one that was here and there was one that was here. So when you plot these points, you're going to notice that you have a pair of points that are on top of one another. And as soon as you have a scenario like this means it is not a function. Okay, so that's another way to think about it. All right, this is something called the mapping diagram. Has anyone here taken computer science or any sort of computer course? Okay, have you seen this before? Like an input and an output? So this first little oval is your input, and this one is your output. Another way to think about it is these are your x values and these are your y values. So this is like saying, if the arrow is pointing to 8, this is like saying 3. So I'll kind of just write it over here. 3, 8 is one of the points. This one would be 6, 8. This one would be 9, 11. And this one would be 12, 11. Okay, so you just look at the starting and the stop point, and then that's your ordered pair. Those are your 2 coordinates. So is this a function? Do we have any x values that repeat? No, 3, 6, 9, and 12, they're all different. None of them repeat. All right, now let's look over here. If I were to graph this, if I were to put this in the ordered pair form, 1 is paired up with 3. And then 3 is paired up with 5. So we're okay so far. And then 5 is paired up with 2, but 5 is also paired up with 4. See how this 5 has 2 arrows coming out of it? So is this a function? No, because it has 2 x values. That means if we were to graph this, there would be 2 dots that are on top of one another, and that's not allowed to happen in order for it to be a function. After the third example, do you guys kind of see the trend over here? We're looking at the x's and we're trying to see repeating values. Rishi? You're allowed to have the same y values, yes. You're allowed to have the same y values, but not the same x values. Oh, so that's actually a good point. How come here we had 8 and 8 and 11 and 11? That's allowed. We don't care about the y values. We're only looking at the x's. All right, finally, my favorite part, the graph. Here is a graph of a function, and here is a graph of something that is not a function. How can we tell if it's a function or not? There is something called the vertical line test, and it's very not complicated. All you do is you're going to take a pen or a pencil or a ruler, and you're going to go from the left-hand side of your graph all the way to your right-hand side. So you're going to move the ruler around, and you're going to see how many times that graph passes through my pen. And do you notice that in this graph, as I move my pen across, the graph is only passing through the pen once? That means it's a function. But over here, take a look. I'm passing my pen, but uh-oh, look what happens over here. How many times is my graph going through my pen? Like multiple times, right? Do you notice how it's going through? So another way, if you can't visualize it that way, is imagine I'm just drawing lines. So I have a line over here, over here, over here, over here, over here, over here. Every time I draw a line, my graph is going through this line only once. However, if I were to draw a line over here, look what's happening here. At this line, it's going through it 3 times. Over here, it's going through the line twice. Over here, it's going through the line twice. Do you notice that the line is in 2 different places on this graph? That means this graph is a function because it passes the vertical line test. This graph is not a function because when you pass your line through, it crosses the graph at multiple different places. It basically means that over here, you have 2 values on top of one another, and we're not allowed to have that. So that means it's not a function. Question, Brianna? Okay, so any sort of relationship is always a relation. If you pair 2 numbers together, it's a relation. If you draw some sort of graph, it's a relation. But in order for it to be a function, it has specific rules where you can only have 1 x value for every y value. So all of these are functions, but that means all of these in this column, we would call them relations. They're related to each other. There's a relationship between the x and the y, but it's not specific enough for it to be a function. Here's what you guys are going to do in your new pairs. There is a sheet on the back with 30 questions, and I'm asking you, is it a function or not? You're going to use the rules I've just shown you on the other sheet, and you're either going to write F for function or NF for not function. I'm going to give you maybe 4 minutes to go through this, and then work with your partner, and then we'll take up a couple of them. All right, you guys, so now we have a pretty good grasp of what a function is and what a relation is. Now we're finally ready to start talking about the word. We're finally ready to start talking about the word quadratic, but I thought the best way to introduce the word quadratic is to compare it to the line, which is something we're familiar with. So for this section, and this is the thing we're going to do before our break, then when we come back, we'll start graphing. We're going to talk about the difference between something that is linear, which is a line, and something that is quadratic, which is not a straight line. All right, so the best way to explain this is let's go ahead and graph a line. So the linear function y is equal to x. Let's go ahead and graph it. I didn't give you a fancy equation at all. I kept it very, very simple. So it's just y is equal to x, which means if x is -2, what's y going to be? -2. If x is equal to -1, -1, 0, 1, and 2. Okay, we're going to take this information, we're going to put it on our graph, and we're going to see what we get. But there's really no surprise here. We know we're going to get a nice straight line. For this unit, although we're not going to be graphing too many straight lines, I do want to make sure you guys have a ruler because you will be drawing axes and things like that. So please make sure you bring a ruler to class. Because we're going to be graphing a lot. Also, as a reminder, when you're graphing, make sure you put arrows on both of your ends, and also make sure you label your lines. So the equation for this line is y is equal to x. Do you guys remember from grade 9, or maybe you didn't learn it? Do you know what the word first difference means? First differences? Okay, first differences are literally the difference between your y values and the table of values. So I'm just going to be looking at the difference. What's the difference between -2 and -1? Okay, so this is going to be a 1. What's the difference between -1 and 0? 1. What's the difference between 0 and 1? And what's the difference between 1 and 2? Just a 1. Basically, every single number is going up by 1. That's what the first difference means. And you're going to notice that in a line function, all of our first differences will always be the same. So whenever we have a linear table of values, you're always going up by a consistent amount. It's always going to be going up by ones or twos or fours or tens or hundreds, but the numbers will be very consistent. Okay, now we're ready to graph our new function, which is called the quadratic. So we're going to do this part a little slower, and then we're going to look at the difference between linear and quadratic. Samira? Yeah, we're just looking at these numbers and we're basically subtracting them and seeing what we get. So I always go from a top, like from top, bottom to top. So 2 take away 1 is 1. 1 take away 0 is 1. 0 take away -1 is 1. -1 take away -2 is 1. So I'm basically asking you, how much is all of these numbers going up by? And the answer is 1.
So it's like,
The difference, yeah. Jordan?
will you just give us like the X numbers or give us
I could give you an equation, just give you the x's, ask you to figure out the y's, and then tell me the difference. Or I could just give you the whole table of values.
okay, so like the X has like everything.
No. Yeah. If it is blank and you can pick your own, I always pick -2, -1, 0, 1, and 2. So you could just put those values in. All right, here is what a quadratic equation looks like. Y is equal to x squared. What do you notice already about the difference between a linear equation and a quadratic equation? What's the biggest difference between these two? Krishna? X is not the same as Y. In fact, what does it have? Yeah, it has an exponent. So every single quadratic equation, now we're going to be looking at exponents. So that's one really big difference. Let's go ahead and fill out this table of values. So you have to be a little bit careful with this because you're squaring it. If I put in an x, 3 where the x is, what's 3 squared? Just a 9. How about 2 squared? 1 squared? 0 squared? Okay, careful. What's -1 squared? Yeah, because -1 times -1 is still a +1. What's -2 squared? Good. And what's -3 squared? 9. Excellent. All right, go ahead and graph this. And I'm telling you now, the graph is going to be something that is not a straight line. It's going to be a curved line. I also have to have a little disclaimer, you guys, with this tablet that I write on, my curves are so not proper. Like I struggle with this. Yay. You guys, let's talk about this curve that we've drawn. This curve has a very special word. Does anyone know what it is? Starts with a P, Hershey? Yeah, this is known as a parabola, which is the main shape we're going to be looking at. And then again, let's look at first differences. So first differences are we're just subtracting and seeing what we get. So I'm going to subtract 9 and 4, and I'm going to notice that the difference is just 5. Then I'm going to subtract 4 and 1. I'm going to notice the difference is 3. And then 1 take away 0, 1, 0 take away 1. Yeah, 1 or -1, 1 take away 4, -3, and then 4 take away 9, -5. What's the biggest point that I'm trying to make here? Are my first differences the same? No. So for a quadratic, we're going to notice that our first differences are going to be different. We're going to be going up by amounts that are not equal. So you're not just going up by 2s, you're not going up by 3s, you're going to be going up by many different amounts. Okay, so we've already talked about the difference between in an equation, in a linear equation, all of our degrees are going to be 1, whereas in a quadratic, they're always going to be squared. For the first differences, if they're all the same, that means it's a linear function. And if they're different, it means it's a quadratic function. And from a graph, if you have a nice straight line, that is a linear graph. And if you have a curved line that looks like a parabola, or really any curved line, would be a quadratic. Samir? I wrote it down in these little square things here. So for a graph, a linear function is a straight line, a quadratic function is a parabola. For first differences, a linear function has all the same first differences and a quadratic function has different first differences. And in an equation, both variables are first degree. That means it's always going to be y to the power of 1 and x to the power of 1. However, for a quadratic function, your x value is going to be to the power of 2 and your y value is going to be to the power of 1. Questions about this? Okay. The last thing we're going to do before our break is we're going to talk about the parts of a parabola. So we've already drawn this. There's really no math to this. You're just looking along with me and following along. If you want to just make some helpful hints, you could do that. But turn to this sheet over here so we can label the different parts of a parabola. Okay, so every parabola is going to have something called a vertex. And a vertex is just the turning point. It's wherever your parabola kind of dips and makes that bowl shape. So you find that point and you make a little dot and that's called the vertex. So in this example, it's 1, -4. Your parabola can also open up in a different shape. So it can look like a bowl open upwards, or it can look like this and open downwards. So for example, if I were to make a parabola that maybe looked like this, I'll just give you a quick example. So if it looked like this, what would be the vertex over here? Well, you would just count 1, 2, 3, 4. So this is -4. And then count up 1, 2, 3, 4. This is +4. And so our vertex would be -4, 4. Okay, but the vertex is just that point that is the highest most point or the lowest most point. Someone had a question? Hand up. Krishna? It cannot have 2 vertices. No, a parabola will only have 1 vertex. Also, can a parabola open sideways? The answer is no. It will only either open upwards or downwards like this. Okay, so just like a line, our parabola can have a y-intercept. And that's basically the point on the graph, the point on the y-axis the graph passes through. So in this case, I would just label it right here. And this point is 0, -3. So it's basically the same as a line, same concept, you just find it. Can a parabola have more than 1 y-intercept? Think about it. Just because I said think about it doesn't mean you change your answer. Yeah, so the answer is our parabola can only have 1 y-intercept. You were right. X-intercept. So again, the same concept of a line, you're going to look at your x-axis and see where the parabola passes by. But what do you notice? How many x-intercepts can a parabola possibly have? 2. So this parabola has 2, but we're going to do a little inquiry after I'm done all of this to show you that actually a parabola can have no x-intercepts, it can have 1 x-intercept, or it can have a maximum of 2 x-intercepts. But I'll hold off on that. We'll come back to that. How do you write down the x-intercepts? Well, you can just write down the coordinates like over here, -1, 0, or 3, 0. Or sometimes you may see it written as x is equal to 3 and x is equal to -1. That's talking about the roots, which we're going to get to in a later lesson. For now, you can just write it as coordinates. Okay, here's something new. You guys remember in elementary school, you learn about symmetry. What does the word symmetry mean? What's symmetrical? Najib? Yeah, it's like a mirror reflection, right? So if you were to cut that shape in half, it would be exactly the same on one side as the other. So a parabola will always be symmetrical. It'll always be the same on both sides. And so if you were to slice it down the middle through the vertex, that's how you would divide that parabola into 2 parts. That slicing, it has a special word. It's called your axis of symmetry. So this is the line that divides your parabola in perfect 2 halves. How do I figure out what this line is? Well, it's just a vertical line. So you look at which axis it's going through, which will be the x-axis, and you look at what number it's going through. So in this example, this axis of symmetry is going through the x-axis at -1. Sorry, +1. Why did I write -1? It should be +1. And so our equation is going to be x is equal to 1. And we'll do a bunch of examples with this as well. Safir? Vertex? Yep, you could also find them from the x-intercepts, and you can also find them from the vertex. Krishna? Then it's just 0. Yeah, so that's a good question. If we go to our example that we drew over here, and if I were to draw an axis of symmetry, it's actually just going through the origin, which is going to be x is equal to 0. Yeah. I'm going to erase that though, so it doesn't get confusing if you're watching it later. Samir?
Can you read from the vertex one?
Yeah, the vertex is just either the highest most or the lowest most point, and you just identify it, and then you just label the coordinates. So look at the x values and the y values and just list it. Yeah, sure. The symmetry is you look at where your parabola is being sliced in half. So another way to think about it is, okay, if this is my vertex, I know my vertex is right in the middle. So I'm going to draw my axis of symmetry up and down this way. And then to figure out the equation, you just look at what number it's passing through. So it would just be x is equal to that number.
And like what is passing through the axis?
It's always going to pass through the x-axis because it's always going to be up and down.
So what if the rule was kind of not fully on a point, but kind of like in the middle? How would you know what it is?
Okay, remember how I said a parabola can open either up or down? So here are two examples of it. This parabola is opening downwards, and this parabola is opening upwards. You basically just look at which way the arrows are pointing. So if they're pointing down, that means the parabola is opening down. If they're pointing up, the parabola is opening up. If your parabola is opening down, that means your vertex is at a maximum. Tell me how that makes sense. Why does it make sense that this vertex is at a maximum? Krishna? Yeah, the vertex is the highest most point. It's like a mountain. It's the peak of the mountain. That's why it's at a maximum. And then does it make sense why when a parabola opens up, why is this called a minimum? Safir? Yeah, this point is the lowest it can go. Exactly. So when we start graphing our parabolas, I'm going to ask you, does the parabola open up or down? So you look at the arrows, and then does it have a maximum or a minimum? Just look at the vertex. If it's the highest point, it's a maximum. If it's the lowest point, it's a minimum. You guys, that's a lot of terminology to learn on one day. So again, I don't expect you to get familiar with it in like an hour of class. It'll take you some practice. But that's what we're going to do all this week. Just practice this stuff. Okay, take a look at this next sheet. I like the one on the board a little better because it's more colorful. Yours is a little black and white, but that's okay. Here are all of the parts of the parabola all in one. So you have the vertex, which is the lowest point in this case, the minimum. You have your zeros or your x-intercepts. Don't let the words confuse you. I'll talk about the word zeros after. For now, we're just going to call them x-intercepts. And they're where the parabola is passing through the x-axis. You have one y-intercept right there. That's where the parabola is going through the y-axis. And then the axis of symmetry is what's dividing the parabola in half. The numbers are all over here. But what I want you to do right now is just see if those numbers make sense. So figure out what the vertex is and then just confirm your answer at the bottom. The same with the axis of symmetry and the zeros. I'll give you a minute to do that. And then we'll do just one last question before we stop this lesson. Okay, so you guys remember when we were just talking about the x-intercepts, I said that there could actually be 0, 1, or 2. Let's go ahead and investigate that a little bit more. So the bumblebee asks, how many times can a parabola cross the x-axis? So the first part of the inquiry is, let's draw a rough sketch of a parabola which opens down and has a vertex anywhere in quadrant 1. The first thing you're probably wondering is, what is quadrant 1? We did learn this in grade 9, but maybe you forgot to label your quadrants. This is going to be quadrant 1. This is going to be quadrant 2. This is going to be, I won't use Roman numerals. I'll just go ahead and use regular ones. This will be quadrant 3. and this will be quadrant 4. Okay, so you always start at 1 and then you go in a counterclockwise direction. If our parabola opens down, just show me with your hands, what shape does that look like? A bowl or like a, I don't know what this is, a cave? Cave? What's that? A rainbow, yeah, rainbow, good. It's gonna look like a rainbow. So it has a vertex anywhere in quadrant 1, and literally we can have an infinite different number of answers. All of our parabolas could look different. I'm gonna go ahead and draw mine to look like this. So it opens down and the vertex is in quadrant 1. Some of you may have stretched your parabola out. Some of you may have extended it into here. Doesn't matter. What does matter is how many x-intercepts does this parabola have? Yeah, every single one of our parabolas is going to have 2 x-intercepts. Okay, great. Let's look at question number 2. It says, draw a rough sketch of a parabola that intersects the x-axis only once. So how can we do that? How can we draw a parabola that has an x-intercept of only one? Good guess. Not quite. Amina? Yeah. What would happen if your vertex is on the x-axis? You can draw it in any direction you want. So you could have a parabola that looks like this, or you could have a parabola that looks like this, or anywhere on the x-axis. But in both of these cases, we only have one x-intercept here, and it's wherever the parabola is sitting. Yep. That's what we're trying to say. How many times can a parabola cross the x-axis? It can cross it twice. It can cross it once. And in some cases, it doesn't have to cross it at all. So draw a rough sketch of a parabola that does not intersect the x-axis at all. What would that look like? Safir? Yeah, so I call these the floating parabolas. You can have a parabola that looks like this. You can have a parabola that looks like this. And in either of these cases, will the parabola ever cross the x-axis? The answer is no. In this case, it'll go up forever in this way, and in this one, it'll go down forever. So here is an example where you cross the x-axis 0 times. Okay, so 0, 1, or 2.